Hi guys, so we have to find the minimum value of f of x for x is greater than 2, where f of x equals e to the power of x over 5x minus 10 plus 3. Okay, so this one is definitely to do with differentiation. So what we're going to do is differentiate the function. So find the derivative of f of x, and then we're going to set that to 0. And that will be the x coordinate to find. Let me just write that, to find x coordinate of minimum point. So of course, doing this will help us find the x coordinate of any stationary point. So in this case, it's going to be, we're assuming that's going to be a minimum if there's one of them. If there's more than one option, we have to determine which one is the minimum point. And then after that, we can substitute back in the normal formula to get the y coordinate of this function. All right, so let's just differentiate the function. So we can use the quotient rule. So we have u of x is equal to e to the power of x. Let me just delete this so we can move this up. So if we have the function f of x is equal to u of x over v of x, then we know that the derivative must be equal to the derivative of u of x times v of x minus the derivative of v of x times u of x, oops, ran a bit out of space, divided by v of x squared. That's the derivative. So if we do that here, we have the u of x equals e to the power of x. That means the derivative of u of x must be e to the power of x as well. Then v of x is 5x minus 10. So the derivative must be 5. So we can substitute that in to get the derivative of f of x is equal to e to the power of x times v of x, which is 5x minus 10, minus the derivative of v of x times u of x, which is still e to the power of x. And we divide that by v of x squared. So that's 5x minus 10 squared. And we're going to set this to 0. So in doing so, we can multiply both sides by 5x minus 10 squared, and it will still be 0. So we have e to the power of x times 5x minus 10 plus minus 5e to the power of x is equal to 0. Now if we can factor out the e to the power of x, we get e to the power of x times 5x minus 10 minus 5 is equal to 0. So we get that e to the power of x times 5x minus 15 is equal to 0. So we can actually split this into two equations. So e to the power of x can be 0, or 5x minus 15 can be 0. So e to the power of x will never be 0 just because e to the power of x it has an asymptote at 0. Therefore, this we can say is invalid. However, if we try and solve 5x minus 15 is equal to 0, we can get 5x is equal to 15. So x is equal to 3. Therefore, the minimum point is when x is equal to 3. We just have to substitute into the original equation to see what the y coordinate is. So f of x is equal to e to the power of x over 5x minus 10 plus 3. The plus 3 obviously went when we did the derivative of this function. So that's why it's not included. And then we can say that f of 3 is equal to e cubed over 15 minus 10 plus 3, which is equal to e cubed over 5 plus 3. If you want to make this one common denominator, we get e cubed plus 15 over 5. Therefore, the coordinates of the minimum point, we don't even have to test its minimum point because we've only got one point. They're asking for the minimum one, therefore we can assume it's a minimum. The coordinates, or the minimum value they're asking for, so it's not the x value, it's the y value. The minimum value is e cubed plus 15 over 5. And that's that.